Okay, Bismillah ar-Rahman ar-Rahim. We'll continue. I did these problems before. As I said, mainly we have three things. We have the geometrics, we have the, what we have in this section. We have the main definition, which is the nth partial sum, Sn. So if this sequence of partial sums converges to S, then we say the series converge and its limit, or the sum of the series is equal to S, which is the limit of that sequence of partial sums. Diverges if the sequence diverges, then the series diverges. And we have telescopic series, and we have geometric series, and we need to deal with them. And also we have this n term, this for divergence, if the limit does not exist of the n term, or the limit not equal to 0, then the series divergent. This mainly the three things which we have. And I think we did a good number of examples. Let me do more. Okay. Now write the number as a ratio of integers. Okay, what is this number? This number, if you notice, is 2.3. Okay. Let me write it. That will be 2.3 plus 0.17 plus 0.017 plus 0.00017 plus 0.00017 plus. Okay, that will be what? 2.3 plus. This is what? 17 over 10 cubed, huh? Over 1000 plus 17 over 10 to the power 5 plus 17 over 10 to the power 7. Okay. Plus. Notice this 2.3 is not related to the geometric series. Actually, something started and then the geometric series is here. So I can write it 2.3. I can also take 17 over 10 cubed common factor. I have 1 plus 1 over 10 square plus 1 over 10. Yeah, 10 to the power 4 plus this. So let me take this aside. Take this alone. Huh? I need to deal with this one. 1 over 10 square plus 1 over 10 to the power 4 plus 1 over. This is very clear. This is geometric series. And what is A? A is 1, and R is 1 over 10 square. So converges. And what is the sum? Will be A over 1 minus R, which is 1 over 1 minus 100. That will be 1 over 99 over 100. And that is 100 over 99. So plug the number here. So this is 2.3, which is 23 over 10, plus 17 over 1000, times this sum, which is 100 over 99. That will be 23 over 10, which is not related to the geometric series. And this is, I have what? This is cancelled. So I have 17 over 1990. So now take common factor, which is 1990. I have what? 23 times 99 plus 17. Yeah, let me do 23 times 99. That would be what? 7, 2, 18, 20. 7, 2, 18, 20. That will be 7, 7, 2, 2. So that 2277 plus 17 for 1990, which is what? 7 plus 7, 4. It's 4922 over 9, 490. Divide by 2. I have what? 1, 1, 4, 17 is 7. And this is 1990, sorry. This is 4, 19 give me 9, 10 give me 5. Which is this one? So this is the answer. Okay. Determine the series convergence. Convergence find the sum. Very clear. I have two different questions. I have this summation. And I have this summation. I'm doing this because I know they are convergent. Now let me call this 1. I call this 2. So 1. What will be the limit? What is the limit? What will be the sum? N equal 1 to infinity. 4 over n plus 1. That will be the sum n equal 1 to infinity. I need to rewrite this partial fraction. A over n plus b over n plus 1. So I will cover the n, that will be 0. That give me 4. Minus 1, that give me minus 4. So this is the partial fraction. So that will be what? That will be 4 minus 4 over 2. You know what? I can take 4 common factor. Let me get rid of this. 4 common factor have summation n equal 1 to infinity. 1 over n minus 1 over n plus 1. Yeah, that will make it easier. So I have this one is equal to what? Let me write from here. 4 times. This is open the sum. 1 minus 1 over 2. 1 equal to, it will be half minus 1 over 3 plus 1 over 3 minus 1 over 4 plus take n minus 1, 1 over n minus 1 minus 1 over n plus 1 over n minus 1 over n plus 1. Yeah. So this cancelled, huh? So I have what? 4, 1 minus 1 over n plus 1. This is Sn. Yeah, by the way, this is, yeah, sorry, this is Sn equal this. If I take it up to n, huh? Not to infinity, huh? Up to n or up to k. Let me do it. Since I'm writing in terms of n, let me write it as up to k. So this is called them k. Yeah. One. Yeah. So what is the limit? S will be the limit as k goes to infinity of sk. That will be 4. The limit as k goes to infinity of 1 over k plus 1. That will be 4, 1 minus 0, which is 4. So this limit is 4 plus. Now let me do the second one, number 2. This is very, very clear geometric series. Make it in the form, I can make it this way. Summation n equal to infinity, 3 over 4 to the power n minus 1. So A equals 3 over 4 and R equals 3 over 4, which is less than 1. So it converges. And S is A over 1 minus R. What is A? 3 over 4, 1 minus 3 over 4. That will be what? 3 over 4. This is 1 over 4 times 4. That can be 3. So it's 4 plus 3, which is 7. That will be the result. This one, need to be careful with the sum now. Yeah, this is what? Summation A times A is minus 2n over. This is what? 2 to the power half, O to the power 2 minus 2n. Okay. Well, n is starting from 0 to infinity. That will be summation n equals 0 to infinity of what? A times 1 over e square all to the power n over. Here I have 2 times 2 to the power half times 1, which is 2 to the power 1. Huh? times 2 to the power half times 2 to the power minus n. So that'll give me what? Summation n equals 0 to infinity e over 2 times what? I have 1 over e square to the power n over 1 over 2 to the power n. So that will be summation n equals 0 to infinity e over 2 times 2 over e all to the power n. Is it? Yeah. 2 over e square, sorry. 2 over e square. 2 over e square all to the power n. Okay. Now it's geometric series. Very clear, this is geometric. Series with r equal 2 over e square, which is less than 1. So it converges. What is a? A when n equals 0, the first element. Yeah, if you open it up, it will be what? At n equals 0, it will be e over 2 plus e over 2, 2 over e square, e over 2, 2 over e square square, and so on. So a equal e over 2 and r 2 over e square. So that implies s, which is the sum, will be a over 1 minus r 2 over e square. That give me what? That give me e over 2 times 1 over e square minus 2 over e square. And that will be e over 2 e square over e square minus 2. That will give me e cubed over 2 times e squared minus 2. So the series converge. Yes, its sum is this. Yeah. What about this? Find the sum of this series. Like what we did in this one, I will split it in 2 parts. Then I will do each part alone. This one will be summation n equal 1 to infinity. 3 over n plus 1. First one. Plus summation n equal 1 to infinity. 1 over 2 to the power n. So I call this one, I call this 2. I'll do the first one, then I'll do the second one. Okay. So 1, I need to do this summation. 3 n plus 1, which is, I can take the 3 outside. That will not make a difference. I have 1 over n plus 1. That will be 3. What is this? Summation n equal 1 to infinity. A over n plus a over n plus 1. So n equals 0, that will be 1. N equal minus 1, that will be minus 1. So I have 3 summation n equal 1 to infinity 1 over n minus 1 over n plus 1. What will be sk? Let me call sk, which is a1 plus a2 plus ak minus 1 plus ak. That will be what? a1 1 minus 1 over 2 plus 1 half minus 1 over 3 plus 1 over 3 minus 1 over 4 plus blah 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 plus 1 over k minus 1 minus 1 over k plus 1 over k minus 1 over k plus 1. This is cancelled. So that gives me 1 minus 1 over k plus 1. So it will be s, will be the limit as k goes to infinity of sk. That will be the limit. Don't forget the 3. Sorry, forget the 3. 3, all of this. That will be 3, all of this. So I have the limit. 3, I can take it outside, will not make a difference. 1 over k plus 1. That will be 1 minus 0, which is times 3, which is 3. So this is 3. First one is 3 plus. Now the second one, summation n equal 1 to infinity, half to the power n, which I can write is summation n equal 1 to infinity. You can take half to the power n minus 1 to make it in the 4. So a equal half, and r is equal to half. So it will be s converges, So s will be a over 1 minus r, which is half over half, which is 1. So it will be 3 plus 1, which is 4. That will be my answer. This will be 3 plus 1, which is 4, which is this answer. Okay. Now this is not the problem, but just to be sure that we understand dealing with the series. Assume this series is converged. Check this series. What will happen? If you notice, this one is what? I want to compare it with this one. Actually, if in the first one, n equal 1, I have 1 over 1 plus 1. 2, I have 2 over 8 plus 1. 3, I have 3 over 27 plus 1, plus the summation n equal 4 to infinity, n over cube plus 1. I know this one converge to a value, to s. I don't know what is s. So what will happen to this series? It will be a number, زائد a number, plus a number, plus a number. So for sure it will be converged. It will converge. To what? To this, which is half plus 2 over 9 plus 3 over 28 plus s, which is what this series converges to. Okay. Bouncing ball problem. Okay. He said the ball is dropped from the height of 6 feet. Okay, 6 feet. And heights and begins bouncing. That bouncing as shown in this figure. The height of each bounce is 3/4 the height of the previous. Okay, what will happen? Let me say this, the ball starting from here, is starting point. It will hit the ground here. So the first time hits the ground, what will be the distance? All of this. All of this is what? D1 equals 6. Then it will go up, then go down again. So what will be the distance traveled in the second step? It will go up, then go down. It will go up 3/4 of this. So this will be D2 will be 6 3/4, because it was 6, then 3/4 of that, because it says 3/4 each time. Up and down. This is up, then again down. So it is 12 3/4. This is the distance traveled, which is D2. Let me do a different color. Yeah, D2 means it go up, down, then go up, then go down. This will give me D2. Yeah, D1, this will give me, this is D1, and this is D2. Yeah, from here to here, this is D2. D3 will be what? It will be, now this is the height reached. So I need 3/4 of this height. And what is this height? it will be 6, 3 over 4. I need this height, 3 over 4 of that. But it's going up and down. This is up, this is down. So 6 over times 3 over 4 times 3 over 4, 3/4 of that. And again, so the total vertical distance traveled will be what? Total will be D1 plus D2 plus D3 and so on. That will be what? 6 plus, that will be, by the way, what? It will be 12, 3 over 4 square. So that will be 6, 12, 3 over 4 plus 12, 3 over 4 square, and so on. Which is, for sure, it will be 12, 3 over 4 cube, and so on. Okay, now I need to find this. Take out this 6 will be alone. This is equal 6 plus. Now I can take 12 common factor. What is the remaining? 3 over 4 plus 3 over 4 square plus 3 over 4 cubed. This is geometric series. This one geometric. And well, what I have A starting point 3 over 4 and R also 3 over 4. So it's converges. And what will be that? This is 6 plus 12. That will be A, which is 3 over 4 over 1 minus 3 over 4. So it will be 6. This is 1 over 4. Zai 12 times 3, which is 6 plus 36, which is 42 feet. Yeah, that will give me the answer. 42 feet. Or the unit he's using feet, so this is feet. Since he's using feet. Okay. Find the sum of the following series. This series. N equal 4. Yeah, you can do it in 2 ways. One way is try to open this. This will be what? 1 over 5 to the power 4 plus 1 over 5 to the power 5 plus 1 over 5 to the power 6 and so on. So what is this? Is geometric, very clear geometric. So what is A? A is 1 over 5 to the power 4 and R, I'll divide this by this, it will be 1 over 5. Which is clear. Also clear of this by this, I'm getting 1 over 5. So I like 1 over 5. So this is less than 1, converges. So I have positive and less than 1. Huh? I need absolute value of R less than 1, which is okay. So it will be S, will be A over 1 minus R. So it's 1 over 5 to the power 4 over 1 minus 1 over 5, which is 1 over 5 to the power 4. This is 5 minus 1, 4 over 5 times 5 over 4, which is 1 over 4 times 5 cubed. Now you can leave it like this. This is one way to do it. Another way, if you want to write it in the format, now if you remember the format, I have what? I need to write it, summation n equal 1 to infinity, a r n minus 1. Okay, so you want to write this series in summation from n equal 1. From n equal, yeah, from n equal 1. How to do that? You have summation n equal 4 to infinity, 1 over 5 to the power n. I want this to be n equal 1. Or, yes, I can say this one is a summation and equal 1 to infinity of this minus, or let me do it the other way. Let me think of it the other way. Yeah. By the way, I get the answer, but now I'm trying to deal with the, assume I have in, I want to start with this. This one will be what? It will be 1 over 5 plus 1 over 5 square plus 1 over 5 cubed plus summation in equal 1 to infinity of 1 over 5 to the power n in equal 4. Sorry, this is in equal 4. And this is my target. This is my target. So it will be the sum n equal 4 to infinity, 1 over 5 to the power n. This summation n equal 4 to infinity, 1 over 5 to the power n. That will be what? Summation n equal 1 to infinity, 1 over 5 to the power n minus 1 over 5 minus 1 over 5 square minus 1 over 5 cubed. I took this to the other side. This one, I can write it in the format, make it summation n equal 1 to infinity. Yeah, this will be 1 over 5 times 1 over 5 to the power n minus 1. What this? This is 5 cubed. If this 5 cubed, I have 25 plus, I took minus as a common factor, plus 5 plus 1. Okay. And that is what? That will be a is 1 over 5 over 1 minus 4 over 5 minus 31 over 5 cubed. Okay. This is 5 minus 4, which is 1 over 5. That will be 1. I'm not getting the same answer. Why is that? There's something wrong. Is 1 over 5 to the power 4. That will be my A starting point. And R is 1 over 5. Yeah. No, sorry. R is 1 over 5. So that give me what? 1 over 4 over 1 over 4 over 5. That will be 1 over 4. Minus 31 over 5 cubed. Still. 5 to the power n, 1 over 5 times 1 over 5 to the power n minus 1. So A equal 1 over 5. I have 1 minus 1 over 5. That will be 4 over 5. So that's 1 over 4. And this one, I took 5 cube common factor. 25 plus 5. Yeah. 25 plus 5 plus 1, which is 31. Yeah, let me try to do this here, just to save time. I have 5 cubed, which is 125, minus 4 times 31, over 4 times 5 cubed. I think it's the same answer. It's 125. What is 31 times 4? It will be 124, yes. Which is the same answer. Yeah, which is the same answer. So sometimes I need to rewrite, to learn how to rewrite the geometric series in different starting point. I have n equal 1, it's this one. So this one, if I have n equal 1, If I want to write it summation n equals 0, how to write it summation n equals 0? And I want this to be n, so I let t equal n minus 1. So I have n is t plus 1. So now I change everything. So that will be equal summation. And instead of n, I write t plus 1 equal 1 to infinity, 1 over 2 to the power t. That means take 1 to the other side, I have summation, t equals 0 to infinity, 1 over 2 to 210. These are them variables. I can say it's n goes to infinity, 1 over 2 to the power n. Now assume I want it starting from 5. Okay. So that means I need to go from n equal 1 to n minus 5. So I let t, this is 1, 2, let t, this is 1, this is 2. I let t equal what? Starting from 5 instead of 1. So I want t plus 6, t plus 4. So it will be equal t plus 4. So I let t plus 4 equal n. Or let n equal t plus 4. Or t equal n minus 4. Or t equal n minus 4. So let me see what will happen. So summation n equal 1 to infinity, 1 over 2 n minus 1 will be t equal n minus 4. So n equal t plus 4. Yeah, that will not do it. I think n plus t plus let me be careful. Yeah, I need to change n minus 1. I want to go to n minus 5. So it means I need to do what? I need n to be t plus 6. Yeah. Yeah. So I write let n t plus 6. So what we have? Summation n equal 1 to infinity, 1 over 2 n minus 1. Okay. N minus 1 t plus 6 minus 1. So let's start from n is t plus 6. So t plus 6 equal 1. Yeah, let me think of it a different way. I need to change the we want this to be n equal 5. So I'll put t equal what? Look, I need to go from here to here, not the other way. So I will write it. If I write t plus 6, then I have, no, if I write it t minus 4, sorry. If I write it n, look, I need to go from here to n minus 5. Yeah, so I need to make n t minus 4, starting from here to here. I write t equal n minus 4. Yes, that will make it 2 to the power n minus 1. If n equal t minus 4. I need to go from here to there. So I take n t minus 4 to do this change. So I have what? Summation n, which is t minus 4, equal 1 to infinity, 1 over 2 t minus 4 minus 1. That will make it summation t equal 5 to infinity, 1 over 2 t minus 5, which is this one. Now let me do the third one. I have n minus 1, third one. I have n minus 1. I want to take it to n plus 4. So I will add what to here? I will add, to make it n plus 4, I have t plus 5. Yeah, so I'll make n 3 plus t plus 5. That will change this to this. Yeah, the third one, I have summation n equal 1 to infinity, 1 over 2 n minus 1. I'll change n to t plus 5. That will be t plus 5 equal 1 to infinity, 1 over 2 t plus 5 to the minus 1. That will be summation t starting from minus 4 to infinity, 1 over 2 t plus 4, which is this one. Yeah, change t now to n. Okay, these are just dummy variables. Yeah, hopefully it's clear. Now he gave me A and R, and he told me this is a geometric series. What will be the series? I know that will be summation n equal 1 to infinity, A R to the power n minus 1. So I rewrite it, n equal 1 to infinity. A, what is A? 1 over 9. R, which is 1 over 3 to the power n minus 1. And what is that sum? It will be A, and the sum is A over 1 minus R. And that will be A, which is 1 over 9 over 1 minus R, 1 over 3. 1 over 9. Let me do it here. 1 over 9. This is 2 over 3 times 3 over 2. That will be 1. That will be 3. That will be 1 over 6. Yeah. How to do this sum? Minus 1 to the power n times 5. If you notice it, this is what? This is 5. I can take it out. I don't care about it. This is minus 1 over 4 all to the power n. If you open it up, let me take the 5 outside, multiply by 5. That will be what? At n equals 0, it will be 1. At n equal 1, minus 1 over 4. At n equal 2, minus 1 over 4 square, and so on. So look at this. A equal 1, and R is minus 1 over 4. Note that absolute value of R is than 1, so it converges. And what will be that? That will be 5 times, what is this sum? A, which is 1 over 1 minus R, which is minus 1 over 4. That will be 5, 1 over 1 plus 1 over 4. That can be 5 times 1 over 5 over 4. That will be 5 times 4 over 5, which is 4. So this is my answer. Express this repeating decimal as a ratio of 2 integers. What is something before? That 5.232323 dot dot. That will be 5 plus 23 over 100 plus 23 over 1,000 and 10,000 plus 23 over 1,000,000. 6 zeros plus 5 is not related to that. So this is, I take 23 over 100 common factor. What's the remaining? 1 plus 1 over 10 square, which is 100. 100 times 100, plus 1 over 10 to the power 4, and so on. So I care about this. This is A equal 1 and R equal 1 over 100. Absolute value of R less than 1 converges. And that equal A over 1 minus R, which is 1 over 1 minus 100. That will be what? 100 over 99. So this one will be 5 plus 23 over 100 times 100 over 99. And the answer is 5 plus 23 over 99. And that will be what? That will be 99 times 5 is what? 495. That will be 495 plus 23 over 99. And that will be 8, 1, 8, 1, 5 over 99. Yeah, and that will be the answer. Find the sum of the following series. How to do this? Yeah, this I can split it into 2 parts. Summation in equal 1 to infinity. This is 3 over 6 all to the power n minus 1. Minus 1 over 6 all to the power n minus 1. Yeah. And that, let me make it 2 different series. This is half to the power n minus 1 minus 1 over 6 to the power n. I know they are convergent, so I can do this. Yeah, this one is read in the format, and this is my A. It's 1. And here the same thing. A is 1. So this is A here, A equal 1 and R equal half. Converges. In A equal 1 and R equal half. Converges. So I have what? A 1 over 1 minus half. This is the first one. Minus 1 over R equal 1 over 6 here. 1 over 1 minus 1 over 6. That give me what? 1 minus half, this is half, that will be 2 minus 6 minus 1, 5 over 6 minus 6 over 5. That give me 10 over minus 6, which is 4 over 5, which is this one. Now what about this one? It's easier. This one will be, you can take 4 common factor outside and equal 0 to infinity. 1 over 2 to the power n. Or I can write it half to the power n. If you want to make it in the format, or I can say 4, open it up. Half to the power 0 is 1, plus half square, and so on. So that'll give me what? 4. Yeah. This is geometric. And what is A? A equal 1. And R equal half. So that implies S is 1 over 1 minus half. And that will be what? 2. So this is 4 times 2, which is 8. So this is the answer. Correct. Yeah, I think we did a good number of examples. Now let me go to the old exams. I think the long video. We're going to say what? I will stop the recording. And then next recording, I will do all the exams. Yeah, I'll do a good number of all the exams. Thank you.